In this video, we will be trying to get the factors of a polynomial equation using factor theorem. Let's consider a function f of x. Now this theorem states that if f of 3 equals 0, then x minus 3 must be a factor of the function f of x. The 3 here is called the 0 of the function, and that means if you start replacing every x from your equation by 3, the equation will equal to 0. And since we replaced every x by 3, x now equals 3, and we can get the factor by getting the 0 of this equation. Getting the 0 essentially means equating it to 0, and we do that by transposing this number 3, to the other side of the function. And recall that if you transpose anything or any term to the other side of the equation, corresponding change in signs should occur. So this positive 3 now becomes negative 3, and now this just equals 0. So that's how we arrive at the factor x minus 3. Let's try an example to better understand this. Suppose we should factorize 2x cubed plus 5x squared minus x minus 6. Now the first thing to do is we consider the constant term negative 6 and try to factor it. Positive negative 1 times positive negative 6 can equal negative 6. Positive negative 2 times positive negative 3 can also equal negative 6. Now essentially, these four numbers are going to be our main guesses in getting the 0 of our function. Let's start with positive 1. So we're just going to replace every x with positive 1. And we solve this, and we arrive to an answer of 0. Now this means that x equals 1, or if we get zeros, x minus 1 is a factor of our function. Now given one factor or 1 0, we can now start dividing this factor by our equation. So 2x cubed plus 5x squared minus x minus 6 divided by x minus 1. So in dividing polynomials, we would divide it just like any other numbers. But let's focus on the first term more. 2x cubed divided by x is just 2x squared. 2x squared times x is 2x cubed. And let's also multiply 2x squared to negative 1. 2x squared times negative 1 is negative 2x squared. And then subtract. This cancels out. And 5x squared minus negative 2x squared is positive 7x squared. Negative x comes down. And do the process all over again. 7x squared divided by x is just 7x. And we distribute that to x minus 1. And subtract. Negative x minus negative 7x is positive 6x. Negative 6 comes down. And that's what we like to see, because now we are arriving, or we seems to be arriving at a remainder of 0. 6x divided by x is 6. And 6 times negative 1 is negative 6. If we subtract that, we arrive at a remainder of 0. That means that we prove that x minus 1 is indeed a factor of our function. And now, we're left with a new equation. Notice that we just factored our original equation into two factors, but this term can still be factored out more. So let's do that. Now in factoring polynomials with leading coefficient greater than 1, we need to make them into 4 terms so that we can factor by grouping. We do that by taking the leading coefficient 2 and the constant term 6 and multiplying them together. 6 times 2 should equals 12. And then let's factor 12. We need to think of numbers that multiplies to 12 but adds up to 7. 3 times 4 multiplies to 12 and adds up to 7. Next, we need to rewrite our equation, but this time replace 7x with 3x and 4x. Now we can group them into two sets and then start getting the greatest common factor. The greatest common factor of 2x squared and 3x is just x. If we take away x from 2x squared, we're left with 2x. And take away x from 3x, we're left with 3. The greatest common factor of 4 and 6 will be 2. 4x divided by 2 is x, 2x, and 6 divided by 2 is 3. Let's factor out by taking away 2x plus 3, and we should be left with x plus 2. Now this is the factor of this expression. So let's replace what we have on the top with these two factors we just got. Notice that we just factored our original expression 2x cubed plus 5x squared minus x minus 6 by using the factor theorem. And this will be our final answers. Now let's try this one. Factor the equation x cubed minus 4x squared plus x plus 6 given that 3 is a 0. Now if we're already given a 0, that means we can easily determine the factor, which in this case is x minus 3. Now given the factor, we can proceed to dividing our function by our factor. But let me show you another method called the synthetic division in dividing polynomials. The first thing to do is, you copy all the numerical coefficients from your function 1 from x cubed, negative 4 from your x squared, to 1 from your x, and the constant term 6. The given 0, which in this example is 3, goes here, and you proceed into the division. 1 goes down, and 3 times 1 is 3, and then you add negative 4 plus 3 is negative 1, and then multiply 3 times negative 1 is negative 3. 1 plus negative 3 is negative 2. 3 times negative 2 will be negative 6. And notice that 6 plus negative 6 is a 0. That means the remainder is 0. Now these results should be your new function. So from here, you take the highest exponent from your function and subtract 1 from it. So in this case, x cubed is our highest exponent, and we subtract 1, that means 1, and 3 minus 1 is 2. We copy negative 1, and the next exponent should be x raised to 1, or simply x, negative 2, and then x raised to 0, or just 1, and then your remainder is 0. This will be our new function. Now notice that we just factored our original expression into two factors, but this one can still be factored. Now what number multiplies to negative 2 but adds up to negative x? Well, 1 times 2 multiplies to 2, and now we just have to figure out where to put the negative sign in order to achieve negative 1, or if we add the two numbers, we achieve negative 1. 1 plus negative 2 equals negative 1. So we will use these factors to factor out x squared minus x minus 2. Now this will be the final answer, or the final factors of our original expression. So that's how you factor a polynomial using factor theorem. Now let's talk about remainder theorem. So what remainder theorem states is that if you're given a function f of x and a factor x, and let's say minus 4, this should equal f of 4, or simply if you're replacing every x variable from your function by 4. So let's give it a go with an example. So we're asked to find the remainder when x raised to 4 minus 10x squared minus 9x minus 20 is divided by x minus 4. So we know the root is 4, and we're solving for an equation given a function. So according to the remainder theorem, if we substitute 4 to all of our variable x, we should be able to get a remainder of some value. So let's do that. Replace all x's by 4 and solve. Now if we evaluate our function at x equals 4, the answer will be 40. Now according to the remainder theorem, we should be able to get the same result if we divide our function by the factor x minus 4. So let's prove that. Now using synthetic division, we copy all of our numerical coefficients 1 from x raised to 4. And notice that we are missing x raised to 3. And in an arranged polynomial like this, if you are missing a term, don't skip it. Instead, replace it by 0. So x of 3 is missing, so replace by 0. Negative 10 from x squared. Negative 9 from x. And negative 20, our constant term. Our factor is x minus 4. That means the 0 is positive 4. And we write it here. Now in synthetic division, remember to multiply and then add and repeat the process. So let's bring down 1 and multiply 4 and 1. 4 times 1 is positive 4. 0 plus 4 is 4. 4 times 4 is 16. And negative 10 plus 16 is positive 6. 6 times 4 is 24. Negative 9 plus 24 is 15. 15 times 4 is 60. And negative 20 plus 60 is 40. Now notice that our remainder is the same. And that will be the remainder theorem.